Hey everybody, what's good? What's going on? JB here with another CyberInsight live stream. Today we're going to be doing a little bit of another practical lab talking about DNS today. Let me just make sure that all my streams and stuff like that, and then we can hop right into it. So let me just check. That looks good. Looks good over on... Yep, okay, good on Periscope. All right, I think that we are good to go with that. So, yeah, DNS. The reason why everything breaks whenever there's any issues in our IT organizations or the internet, it always comes back to DNS. So, I'm just going to do a quick overview about DNS as if you've never heard of DNS before, and then we're going to hop into this lab, which should be kind of cool. So, DNS is pretty much like the phone book of the internet, right? So everything device-wise has an IP address, and it would be completely impractical for us to remember or write down the IP addresses of everything that we want to talk to. I mean, even if you just think about within your home network or your work environment, all the different devices that are there that you might need to talk to or your computer might need to communicate with for different types of authentication and stuff like that, it would be impossible for you to remember all of that, right? So what DNS does is it allows us to have, in essence, a phone book that has a mapping of domain names to IP addresses. And it's much easier to remember a website's address, so espn.com, than remembering the 100 different IP addresses that ESPN uses for their web server. So DNS in general, from a ports and protocol perspective, uses UDP port 53. That is used kind of for the lookup portion of that. DNS servers themselves, especially within an individual domain, sometimes we see primary and secondary DNS servers, and they'll share information between each other. And when they do that, that's called a zone transfer. When they do that, that actually uses TCP port 53. But in general, whenever people are normally talking about DNS from a user's perspective, we're referring to UDP port 53. So I did want to just provide a little bit of a quick overview of what happens when you go to do a DNS lookup on something, just in case you're unfamiliar with how the entire process works. So let me just bring up a really cool diagram that will kind of explain this kind of well. Hopefully you can see that. I can probably zoom in on this a little bit more. And let's see if we can move that down just so we see it on the screen a little bit better. All right, so that should look good. So normally whenever we go to any type of website or something like that, let's just use surfing at home, for instance, right? So you're on your computer and you're going to go to a website that you've never been to before. Your home PC is configured to point to a DNS server. It's probably something that's provided by your ISP. So in this case, in this scenario here, they're using a website called abc.com, right? So you're going to go and type in abc.com into your browser. Your computer is going to have no idea what the IP address is for abc.com. So it's going to send out a DNS request to whatever you have configured for your DNS resolution. Like I said, that's probably going to be a server that your ISP controls. And that's also probably going to be a server that we refer to as a recursive DNS server. And what a recursive DNS server means, it's going to be the one that's actually going to pass off these requests to other servers if it doesn't actually know the answer itself. So you're going to request abc.com. It's going to go to your ISP's DNS server. And the first thing it's going to do is it's going to look for the top level domain. And in that case, the top level domain of that address is .com. Actually, I think it's dot. And then it's going to go and look for the com portion of that after that. you might see other top-level domains like .org, .net, things of that nature. Pretty much anything that's at the end of the address is going to be considered your top-level domains. So you're going to get back the IP address of the top-level domains from what are called the root servers. These are the first stop that recursive DNS servers are going to go to look for things if they don't know what the answer is. So the root servers are going to send back what the IP address of the .com domain name servers are. And then your ISP server is then going to do another lookup, this time to the authoritative servers for .com. And they're going to ask the .com authoritative servers, hey, do you know which domain, or I should say, do you know the IP address of abc.com? And the .coms aren't going to know that, but they are going to know the information of where the ABC domain is. So then they're going to send that information back to your ISP's DNS server. And then at that point, your ISP's DNS server is going to have the authoritative domains or the authoritative DNS servers for the abc.com domain. It's going to request, hey, what's the IP address of the website abc.com? It'll get that back, and then it'll provide it back to you in your computer, which then has the correct IP address that you put, that you requested URL for in your browser, and then you're able to make that connection. That is a lot of stuff that happens. It took me probably, I don't know, how many minutes was that? Probably about 4 minutes to explain it, but when it happens on your computer, it happens in a matter of a second or so. So once you actually have that information, though, then that gets cached at different places. So the DNS cache will live for a certain period of time, depending upon how long it's that lifetime is configured for on your DNS server. So if it's something that you go to quite a bit, you don't necessarily always have to go back through that same process of going, through the top level domain and then down to the next levels to end up finding that IP address. So that is a very, very quick high-level overview of DNS in a nutshell. So let's hop into this lab, and we're going to set up something really, really simple. We're going to go back over to Packet Tracer, like we used the other day. And pretty much what we're going to do is we're going to have a host, and we're going to connect it to a switch, and then we're going to have a server on the other end. And that server is going to be doing a couple things. That server is going to act as the DNS server for that PC, and then that server is also going to host a web server on it. So we're going to configure that up, make sure that they're able to ping each other, and then we're going to try and go to the URL of a web server that's there. It's not going to work. Then we're going to create a DNS entry in the DNS server. We're going to look at a few different options that we have for different types of DNS entries, and then once we do that, then everything should work. So any questions so far before I hop into that? Oh, we do have a comment over here. Someone saying hello, hello. Thanks for dropping in. All right, let's see. So as we did in Packet Tracer the other day, a few different things here. So we have network devices. Let me actually have something in my way that I'm not able to see. Okay, so we're just going to go a regular 2960 switch. We actually aren't going to need to do any configurations on the switch today. So this is going to be really straightforward. We're going to go a PC, and we're going to go a server. Okay. And I will try to make these straight, because then they line up, and I won't be bothered by it being all over the place. All right, so if you remember in Packet Tracer, when we want to make connections, we go over to this little lightning bolt thing here. These are all going to be straight through connections, so it's going to be super easy. We're just going to go over here, pick the fast Ethernet port there, connect it to the first fast Ethernet port over there on the switch. Didn't mean to click on that like that. We're going to do another connection off the switch. Going to pick the next available port, and we're going to go to the only available port on the server. So we're going to set these guys up with some IP addresses first off. So we're going to double click into the PC. Let's make this a little bit bigger so everybody can see, we are going to go under the desktop. And on the desktop for the PC, you can do IP configuration. So this is going to be a static configuration. Let's make this 192.168.1.2. Well, it'll auto-populate with a /24 subnet mask, which is perfect in this case. We're going to set the default gateway, even though we don't necessarily need to do it, but I just like to do that whenever I do things, to .1, and the DNS server to 1.1 as well. So you don't need to hit any save buttons or anything like that in here. So as soon as we hit X, if we were to go back and look at it, it was automatically saved. Okay, so we can get out of that one. We'll go over to the server. So if you guessed, I set the DNS server IP address to 1.1. So we're going to do that over here on the server side. So again, I'm going to make this a little bit bigger so you can see it. We're going to go in the IP configuration, 192.168.1.2. Again, the same subnet mask, a /24. Oh, we don't need to set the gateway there. And we will set the DNS server as itself. Oh, I screwed up there, didn't I? There we go, 1.1 and 1.1. Okay. So at this point, let's go check and make sure that we are able to ping each other. So if we go to the command prompt over under desktop on PC 0, let's ping ourselves first. 1.2. Okay, that is good. And then let's ping the other box. So this is the server, and we have connectivity. So that is a good first step. Now, let me just double check my notes real quick. I think that if we, at this point, wanted to go, let's say, I'm just going to make something up. We wanted to go to a website. We're going to go to the web browser that's under the PC. In this case, we're going to go http www.jbcsec.com. It's a good website. Check it out sometime. We're going to go. And we could sit here, and we are not going to see anything. And nothing's going to happen. Okay, so we can also try and ping that www.jbcsec.com, and we're not going to get any response back from that. If this was a real Windows terminal, this would time out, but since this is an emulator, it's not really going to do that. So we're just going to hit Control C. Something else that you'll use a lot when you're trying to find out information about a domain is you can use a tool called NS Lookup. So if we go NS Lookup and a domain that we want to see, it would normally tell you what the IP address is and what your DNS server is. And it has absolutely no idea because we haven't configured anything yet there. So let us go over to the server now. And we will get into this. And we are going to go under Services. And then you'll see that it is running a web server both on HTTP, which is TCP port 80, and HTTPS, which is TCP port 443. If we go under DNS, there's no servers turned on. So let's turn that on. And it gives us a few options for different types of records that we have here. And so I guess this would be kind of like a good time to talk a little bit about different types of DNS records that you might run into. The options that they have here are A records, CNAME, Statement of Authorities, and NS records. A records are probably the ones that you're going to run into the most. And what an A record is it is the, you have a URL or host name, domain name for a website, and it correlates it to the IP address. right? So that's what we're going to put in here. We're going to put in jpcsec.com equals the IP address of the server, right? And a record is specifically for IPv4 addresses. We have something else that's not available here, but it is something that's in real life, and those are called quad A records. And that is the same exact thing, except when you're using an IPv6 address. Another option that isn't in here is a MX record or mail exchange record. You use those for mail servers. Let me see, what else do we have? We'll kind of talk about these here. So a CNAME is kind of like an alias. So you might have multiple names for different websites that you want to have that go back to one domain name, right? So you can have a whole bunch of different names that all point back to one, and then that one has the actual A record correlation between the domain and the IP address. A statement of authority record is really something that's more done on the administrative side. If we actually click down into the options there, you'll see that it has some different things that you can put in there. And really, it's more like administrative information that's used and shared when you're doing zone transfers. So like I mentioned before, when you have a primary DNS server and a secondary DNS server and they kind of sync their configurations, this would be something that would come up at that point. And the last option that they have in here is an NS record. NS record is, or a name server record, something that you see that is used to indicate who the authoritative source is for a domain. So it would tell you that this IP address is the authority for whatever the domain is. And that's going to be something like when we went through that whole flow of trying to figure out what the IP address was for a domain, and it was going back and forth to all these different servers. That would be where something like NS records would come into play. So let's put in a record, and let's go www.jbcsec.com, and we were going to make this 192.168.1.1. Okay, so that is in there. I should now be able to go to my web browser and go http://www.jbcsec.com, and bam, it brings up a web page there that's hosted on the server. Now, something interesting that we can do with this as well is if we go back and let's say we go https://sec.com, we're going to get the same thing. So this is kind of a small point, but it might be something, if you're new to this, you might not know right off the bat, is that you don't need to have different domain names created if you're going between HTTP and HTTPS. That's normally something that's handled actually on the website side of the configurations. All you need is a domain name, and whatever configurations you have within your web server can offer up that domain on, whatever ports it is that you want to use. So if we go back to the desktop here and we go to the command prompt, we should be able to now do a ping, right? That comes through, which is good. We should also be able to do that NS lookup. Yep. So now we see it's telling us what our DNS server is, and it's also telling us the IP address for the correlation between the domain name and the server IP. Now, one last thing that we can do, we kind of talked about the CNAME stuff, is we can go and we can create something like that. So let's create a CNAME, and let's just go jbc.net. And we are going to put it back to this guy, to that domain that we have there. Okay, so we put that in there. That means I should be able to go over and use that domain now. Let's try that, http jbc.net. And that comes up. So, yeah, I think that is pretty much about everything I wanted to cover today. We talked a little bit about, you know, the basics of DNS, how all of that flows when you're going to actually do a real lookup and you're using a recursive server. In the case where you aren't pointed to a recursive server, then your box itself is going to be doing all of those different lookups to the different level domains. And then in the lab, we created an A record, we created a CNAME, used NS lookup as a tool to kind of look at some different things. So yeah, if nobody else has any questions or anything like that, then I think that we can call that a wrap for today's lab. We'll have another lab on Friday. We're going to talk about Telnet, which is an atrocious protocol that you should never use for any type of remote management, but you can use it for some cool troubleshooting stuff. So I think that is about it. And if nobody has anything else, then we will call it for the night. Let's see. All right, everybody take care. Go get at it. We'll talk soon.